Hi everyone, my name is Elie, and today I'm going to tell you about CAPTCHAs, or more likely some sort of the end of it, and I meant it in a very, very serious way. Actually, one of the main questions we had when we released this paper is, shall we go ahead? Because as you will see, basically this paper shows you a generic technique which breaks every known, and I said every known text CAPTCHA in the world. It is a new way. We've been knowing it, and we've been working on it for about 2 years. And we made a lot of choice. And at the end of the day, there was also a startup who tried to show how to use deep learning to break CAPTCHA. So we decided that at that point, there is more value to us to tell you how we do it rather than just keep it and try to improve the defense. So it's also why it's a WOOT paper and not a USENIX paper, is because we don't have a defense. We have an idea of how defense should go, but we don't have a way to tell you, yes, there is a fix. With this along the way, why do we use CAPTCHA? Well, CAPTCHA is somewhat a barrier to entry to automated things that people can want to do for either fame or money. For instance, for fame, you might want to have more Twitter followers, and then you go to a website, and the website will buy you some fake followers, silver pack, gold pack, premium pack, and so forth. One of the ways CAPTCHA I use is not to remove completely this, but simply to put a barrier to entry of, yes, you have to pay some sort of a cost. Mainly today, CAPTCHA breaking is done using crowdsourcing, so you outsource to farmers which are in third-party country, which is also why looking at fully automated and breaking CAPTCHA using expensive AI is not such a huge threat in practice because, well, most of people will already outsource to third party. And then, of course, you have your CAPTCHA, and people type the CAPTCHA. All right, so CAPTCHA is this wiggle letters. There are other type of CAPTCHA. I'm always amazed how many papers I review about new scheme of CAPTCHA along the years. I've been 5 years, I've been working on this. I got so many of those. My favorite one might be the old version, the ASCII art version of the CAPTCHA. Russian are crazy. I don't know even if someone can pass this one. This is the American version where they're more like geographic people. If you like folding, do not, you have 25 seconds to fill this one. And of course, there was the Asira paper, which was like, oh, let's put cute dog and puppy, everyone loves that. Broken, but still nice. And of course, if you do that, someone will troll you and make the hot or not one, which is a... Anyway, so these are CAPTCHAs. These are many prototypes. Most of them are, of course, insecure or have been broken. The one on the left side, which was the most serious attempt by Microsoft, the Asira CAPTCHA, has been broken. But realistically, here's what CAPTCHA look like for major providers. Baidu, CNN, eBay, Google, Wikipedia, Yahoo, all of them use text because it's easier to embed, it's easier for people to process, they know what they should do, and they all rely on some sort of collapsing or line. That's what the state of the art will be, or was. So what is the outline today? Well, first I'm going to tell you a little bit of how we did it before to give you a context, and then I'm going to tell you how we do it now, and I'm going to show you why it works and how it works on everything I showed you before. So, once upon a time, about 15 years ago actually, there was a paper by Louis Vernon who says, well, you can apply machine learning to break CAPTCHA, and the first one was actually about audio CAPTCHA, where you use to discretize the sound and then recognize the spike. And then we started to use this idea of, well, you can discretize, segment, and then recognize using machine learning. And the field of CAPTCHA breaking almost become to life. There is a lot of work on this, and all of this is like thinking Lego. You tear apart the CAPTCHA using one feature at a time, and then when you have tear apart enough defense, you have segments, and each segment is passed to a machine learning classifier. To give you a concrete example, that's one from the CCS paper in 2011. This is the old /.CAPTCHA, so you tear it apart by, oh, let's find all the lines. So here's a canny operator. You remove the line, then you chop the CAPTCHA into segment, you normalize your CAPTCHA into the segment which have the same size, so it's easier for your machine learning. Then you apply machine learning, you get something, and you're like, it's a word, so I'm going to do spell checking, and boom, you have your CAPTCHA broken. That's the segment and recognize approach, right? Very, very 5-stage, 3-stage. People don't agree really on the number of stages, but the idea is first vision or first tricks, and then recognizing each segment one at a time. But how about collapsing, right? Is this really work for collapsing? Well, the answer is there are some complicated heuristic which works on some of the CAPTCHAs. This is one example where they notice that if you tint the CAPTCHA and then you look at the bar on the top right for the T, you might get the T, and then if you go to the U, there are certain and blah, 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 and you have like 25 heuristics. So yes, there is some heuristic for some of the collapse CAPTCHA, but in reality, if you ask real Dom, no, you don't. We don't know. If you really use the segment and recognize, there is no general segmentation technique to segment images. It's a well-known fact. We haven't found a generic algorithm, so in the general case, you don't know how to do it. You can find heuristics, but then people change. So how do you move out of this? Well, first, what is really wrong with the previous approach? What, over the year, we end up in a very, very bad circle, and I actually have my share of this problem as well, where I wrote a bunch of paper with the same approach, where it is like, well, you need to find an invariance. You need to find something in the CAPTCHA which you can use, and you can extract some of biases to actually being able to break it. Whether it's the length of it, the color differences, the shape of it, or anything like this, you use an invariant, and then you tear it apart a little bit. So in reality, the field has moved from, oh, let's use AI to let's find an exploit. Let's find something in the design which is flawed, and let's exploit this flaw, and then fix it and do it again, and do it again, and do it again. That's exactly what the field ended up being. And if you look at the trend of the last, I don't know, 2 or 3 years of papers, they are exactly, oh, I'm going to take scheme X, which has never been broken, and oh, you can see there is a difference if I do this and this and this, and voila, it's broken. And then you move to the next one. So it is not anymore science. It's more like exploit writing. I'm not saying it's not interesting. I'm just saying there is nothing new, and there is nothing who moves the field forward. So how do we move away from this? Well, an interesting observation is actually the best part of the breaker is machine learning. This is the thing which works really well. There was a paper, I think in 2005, which says that a computer was able to beat human on recognizing a single characters, whether you twist it, you put line, you put noise. I mean, for a single character recognition, it's been 10 years since computers are beating humans into recognizing them. So why? If classifiers are so good, why are we still doing pre-processing? Why are we still doing vision? And that's the idea that you should take off the human out of the equation. I mean, humans are not really good at breaking CAPTCHA, truth to be told. Writing heuristic is great for a PhD student, but in reality, I mean, you find it interesting. It's good to learn vision techniques, but at the end of the day, the algorithm will do a better job than you. So if we know the strong point is AI, why are we still using manual technique? Well, we should not. And so that's the realization that we've been working for 2 years. There is no segmentation part. There is no need for it. You should not trust a human. You should not even try to attempt to use it. You should just use machine learning. And that's what we're going to do. So how we do that? We use cut point detection, which is basically the idea that you provide to the algorithm every possible way the CAPTCHA can be cut. And I meant every possible one. It's basically you look at how some wavy, and you make some sort of basic guess, but overall, if there is some sort of possible cut there, you just show all of them. And there is millions of them, yes, but you have all of them. Then you create all the segments based on all the cut points, and you have a ton of those, and then you recognize all of them. Then you recombine them into a chain, and then you decide which is the most likely one because it appears multiple times. Remember, you slice the same character multiple times, so we'll have it. An illustration of the approach, you take your CAPTCHA, you slice it into all possible combination, and you get a graph. You get a huge graph. I mean, this is like a small graph. Some graph for 9 or 12 characters long CAPTCHA are like millions of nodes. Yes, it's complicated. Yes, it's very costly. But at the end of the day, if the CAPTCHA can be read, it can be segmented by your brain, so it can be segmented by a brutal approach. There is absolutely no difference. And then you go and you do basically a walk in every possible chain, and you extract all of them. And that's what you do. At the end of the day, then when you have all the chain, you recognize all the chain at once. And you say, well, the first one is this kind of letter. The second one, which is obviously wrong, there was a miscut, is something else. The third one is the same first one, and then you do voting. and you can do, it's called ensemble learning, right? And you can do more or less complicated voting. Turns out even if you use a simple one, it works. And you get the right answer. That's the idea. There is no human anymore, somewhat. I will tell you why humans are useful, but at the end of the day, you do not have any assumption of what distortion it is, because at the end of the day, you don't care. And so how do we use human? Well, that's the key ingredient which actually makes the algorithm work. So humans still have a place, which is using reinforcement learning. So sometimes the chain is correct, but there is one node which is not correct. Now, the reason why this node is not correct can come from two things. And that's where you basically the algorithm will tell the human, hey, this is something I don't know what I want to. What is it? So what are these two cases where one goes wrong? So the first one is the segmentation went wrong. It's a segment, and the segment doesn't mean anything. So, well, you basically mark it as a human as, well, it's a bad segmentation. Forget about this segment. You didn't make a mistake. It's just badly segmented. Happen all the time. On the other hand, sometimes the algorithm didn't exactly understand the shape of the CAPTCHA, so then it actually tell, well, no, you have to learn that this one is really an A, or yeah, this one is really a 0. You have to learn it. And so these are, like, for instance, 3 examples where the classifier went wrong. For instance, it took an A for a 4, and a B for a 0, and a 1 for a 7, so you have to tell him, no, you're wrong. This is really what it should be. So, and it makes it very, very lightweight, because you don't have to train with thousands of examples. You train with basically 26 examples for each letter at the beginning, and then you just have a few more that you give to the algorithm as it processes and improve, and you can improve and improve and improve. I don't know if you need to do that, but even in doing a single pass drastically improves the performance of the algorithm. So, as I said, if you build this, breaking a long CAPTCHA takes 9 hours. And so, yes, it works, but it's so slow that it's not even practical. I mean, at some point, we gave up. You run it on a laptop, and then you come up the next morning, it's not done. So we had to make trade-off. And we found a couple of ways. The first one is we use a bunch of heuristics where we remove some of the cut points. When I said we're going to take all the segments in the world, it turned out that with some heuristic, inflection point, and eliminating duplicate segments, you can actually reduce the computation. And then you can move to a faster and less accurate recognitions where you look not at the full chain, but just like 2 characters at a time, or left and right, because we know the left side and the right side of the CAPTCHA, so it makes sense to go both ways and just look two at a time. If you want the detail, it's in the paper, but basically we found a way to get the algorithm down to a few seconds per CAPTCHA. It is not as fast, it is not as accurate as a real deal, but it is good enough to break everything. So evaluation on real-world CAPTCHA. Okay, that's the theory. How that works? Well, let me show you first a Yahoo CAPTCHA. Took one example. So you have your CAPTCHA. You find the inflection point. Basically, you just look at where there is some sort of standard second order derivative which have some sort of change, and you cut all of them. So all the blue stuff are basically potential cut point, and then you basically have a ton of those. So we use our heuristics to remove most of them or some of them, and then you can see it clears out. So all the blue line are going to be where we're going to cut the CAPTCHA. And then here are all the cut which are compatible with the start. So we know the start because it's white to black, so we know exactly where it is. And then we have probably 100 different possible ways to cut the CAPTCHA, and we're going to do all of them. And we do that for the next one, and then we move and move. So at the end, here's what basically the algorithm was able to do for segmentation by itself. I didn't do anything. It looks reasonable, right? It's reasonable, and remember, the algorithm is extremely good at recognizing character one at a time, so that's all you need, and you get it right. Here's another example on the reCAPTCHA. That's one of the old one, very old one. I think it's 2001, 2011, sorry. And so same thing, inflection point, all the potential cut. You, for instance, find what is the optimal one. So here's one to illustrate what it looked like. And then you remove all you use some heuristics, then you try to do all the compatible cut for the start, to give you an example of where it is. And then what happened when we use our fast procedure? Well, we get it wrong. We get it wrong because, as you can see, it did a cut, and the H become a L and a U. an L and a V, and it's somewhat reasonable, right? You look at that and you're like, well, I would have get it wrong as well. The reason is because we don't have all the full chain. If you pass the same thing to the full algorithm, well, no problem. It actually works pretty well. So that's the difference between iterative and full chain. The full chain will actually works better. Do we really need that? Well, if you want to get from 20% to 40%, probably. But if you just want to show it's broken, no, not really. OK, so then we got this question about how about lines. Some CAPTCHA have line, and to claim that you have a generic algorithm, you better back it up with breaking everything, right? So how do you break things with line? Well, it turns out that a line is just a shape. And if it's a shape, then you have to tell the algorithm, oh, you know, it's a shape, it's a line, and when you see one, just ignore. And that's all it takes. It seems very simple, but actually it works very, very easily. So you take the same one, same thing, and basically the algorithm finds that the line exists and remove them. And basically now it's a line, and just say, well, it's a line. Don't count it and just remove it. And both works equally well. So at the end of the day, the generic approach either succeed where no one else did, or actually beat previous approach quite easily, except in one case where the guy really optimized. But basically, you can see it's a huge table. Sorry about that, but there is the version with or without reinforcement learning and the time. And you see the running time for left and right, which is our heuristic, is less than 3 seconds per CAPTCHA. And you can see that overall we get like 50%, 20%. Or the Yahoo one, which is very, very long, right? It's like 7 to 8, we get 3%, and just because we haven't pushed the algorithm to the extreme, it's just to show that it works. So at the end of the day, we also looked at comparing with human and say, well, here's a bunch of CAPTCHA, and if you increase collapsing, is there any gap, you know, if we have very high collapsing? Well, the problem is the algorithm drops faster than the human, but the gap is so narrow that you will get like 20% accuracy in human if you really want to have 0 on the breaker. So it's not possible. There is no way for you to make collapsing which would work against this thing. So at the end of the day, I think this is like a turning point where all we did before is gone. Text distortion, there is no need to provide a new one. We know it's going to be attacked, and there is also no way. The way we used to break and think about CAPTCHA is also moved to another way where we move to a pure I part. So, summary: the segment and recognition approach is somewhat deprecated. Use AI, use pure I. That's the way to go. And text distortion defense should not be considered as secure anymore. Use risk analysis. That's what most of the big providers are using anyway, which is like CAPTCHA is one of the many signals that people are using. Thank you.
Luc Desitals with North Carolina State University. Mm-hmm. What do you think about alternatives to letter-based CAPTCHAs? So if I ask a word problem, for example, that would require very good understanding of English to answer, will deep learning get to these, or will it be a long time and will it pass the Turing test first?
I do believe deep learning will beat any type of image-based CAPTCHA, unless you disforce the CAPTCHA to no recognitions. But the recent progress in deep learning probably show that there is no. It's going to be really hard for showing 2 images, right? And say, what is this image? I think they will be doing extremely well. For semantic CAPTCHA, like English questions, I think it's even easier because one thing that people don't realize is when you have to design a CAPTCHA, you're designing it not for 10 people or not the smart people in this room, but you are designing it for the world. So now ask your question, what is a semantic question for 13 years old? Which either live in India, live in Africa, live in the US, have different culture, different knowledge. It's really hard. And you have to come up with a lot of them. Hundreds of millions of questions, so it's difficult.
On a related note, have you encountered any solutions that could be practical right now?
Risk analysis. So you take into account the CAPTCHA, how the CAPTCHA is solved, where the people come from, what is the intent, past history, a lot of things. I think there is no one silver bullet. I think it's a long path.
Thank you for this wonderful talk. Now, I'm among those people that if I'm presented with a reCAPTCHA, I need to like click reload 500 million times until I find one that I actually recognize. So can we get like a Firefox extension, like right click for people like me that are mistaken as computer programs?
I knew I would get this question. All right. We changed.
It's an actual problem for me.
I do understand. And the actual problem had a solution that we did implement. If you were to create an account today or go to a site protected by reCAPTCHA today, you would not see a heavily distorted CAPTCHA anymore. I'm actually making you can put it to the test today. Go to Google, not create a fake account, but go there and try to look at the sign-up page, and you will notice that we only show you street numbers or very simple CAPTCHA, which are way more usable. We actually do risk analysis now, so we only show heavily distorted CAPTCHA where we have a strong suspicion that you are not human. And I think that's the same thing for other people. So no Firefox extension, just good CAPTCHA for everyone. How about that?
Cynthia Irvin, Naval Postgraduate School. So your risk analysis approach, do you believe that it might suddenly become intrusive on personal privacy?
It has nothing to do with privacy because there is no user data into it. There is like characterization. Thank you for the question. We do not, I mean, it's just a decision based on the page. I mean, there's a lot of secrets into it, but basically it's more about what is the computer, where it comes from, and so forth, rather than who is the user. There is absolutely no user data, at least on our side. And I can't speak for any other people because I don't know how they do it.